Good morning. Today we will discuss about the basics of spectroscopy. Before going towards the spectroscopy, we need to learn about some terminology like colorimetry and spectrophotometry. The word colorimetry is used to determine the concentration of various colored species or colored solutions which can be used to see using the human eye. Whereas the spectrophotometry is the instrument used to measure the concentrations of the various substances or any solutes or molecules or proteins present in a solution which could not be beyond the human eye or which could not be seen by a naked eye. Before moving towards the spectroscopy, let's have a glimpses on the electromagnetic spectrum. We all know that in the universe there is a electromagnetic spectrum which is composed of various waves like radio waves, infrared rays, microwaves, UV, that is your ultraviolet rays, X-rays, that we can be used for various and different applications in our day-to-day life. Among all this, what we observe the colors are because of the emission and the excitation of the light radiations present in the visible light. This visible light is only a small portion among all the electromagnetic spectrum. Here, the frequency of the waves is directly proportional to the energy of the wavelength or energy of the waves, whereas the frequency and the wavelength of these waves are inversely proportional to each other. So these are some of the ranges or the wavelength ranges of some waves like UV waves, that is ultraviolet rays, ranges in the wavelength from 180 to 380 nanometers, whereas the visible light ranges from 380 to 780 nanometers, and as the wavelength increases it turns towards the infrared regions. Now let's move towards the main topic, that is spectroscopy. The spectroscopy is a technique which is used to determine the concentration of various substances, whether the colored or the non-colored. The instrument used to determine this is called the technique, or the instrument used to determine the spectroscopy is the spectrophotometer. So spectrophotometer is an instrument that measures the amount of absorbed light or the intensity of the color of a solution at a given wavelength. So how this intensity of the color can be measured is by when we irradiate the particular solution with a particular wavelength of light. So if the molecules are in the resonance with those particular substances, these colored solutions or the non-colored solutions will absorb the light or the energy from this irradiated light and transmits the sum of the non-absorbed. So by measuring the intensity of the absorbed light or transmitted light, we can determine the amount or the concentration of the substances present in a particular solution. Here, moving towards the spectroscopy, we have to determine the two terminologies such as transmittance and the absorbance. Transmittance is nothing but the amount of the light transmitted after the absorption of the light by the solutions or by the solution, whereas absorbance is the amount of the light that is absorbed by these solutions. So what happens exactly is, when the light absorbs it, when the molecules or the substances present in a solution absorbs light, they excite and reaches to the higher level. While reaching to the ground state, they release the energy or in the form of transition. So this movement or transition from the higher energy level to the ground state determines the amount or the ability of the particles to absorb light. These are some of the radiations and the atomic scale interactions of various molecules at different radiations. So this what is absorbance actually is. This absorbance can be explained by a law called Beer-Lambert law, and this Beer-Lambert law is depends upon the concentration of the absorbing molecules as well as the path length. It means as the absorbance, the number of the concentration of the absorbing molecules are high, the amount of light absorbed by those particular solution will be increased. So it increases, we can say that the concentration of the absorbing molecules is directly proportional to the absorbance. Comparing the other parameter, that is the path length. So if the length of as the longer the length of the medium through which the light passes, the more amount of absorbing molecules present in that particular pathway. Hence the path length is also directly proportional to the amount of the absorbing molecules in a particular solution. The spectroscopy or the spectrophotometry depends upon the law called Beer-Lambert's law. By using this Beer-Lambert's law, we can determine the concentration of the molecules, absorbing molecules, as well as the absorbance, if we know the path length and the extension coefficient of that particular molecule. So hence this Beer-Lambert's law can be stated as A equal to ABC, that is capital A is nothing but the absorbance, which is a unitless, and small a is nothing but the molar absorptivity. The units of this is the liter per mole per centimeter square, centimeter. Then B is nothing but the path length, which can be measured in centimeters or meters. C is the concentration of the analyte or the absorbing molecules present in the solution. The units of this C is mole per liter. So now let's see what are the factors influencing this absorbance of a sample. First one, the foremost is the concentration of a solution. See, if there are the concentration, as the absorbance is directly proportional to the concentration of the solution, is the foremost property or the foremost factor that influences its absorbance. So it depends upon the how many molecules present in the solution. So though there are number of molecules, the absorbance is mainly affected by the how many molecules are being interacting with the light. Suppose if you have got a strong closed colored organic dye, if it is in a reasonable concentration, it will have a very high absorbance because there are a lot of molecules to interact with the light. However, if we consider a diluted solution, though the solution volume is more, as it is diluted, the colored molecules are very less in a diluted solution, so the absorbance will be very low because the number of molecules which are being interacted with the light will be very low in a diluted solution. So the next factor that is influencing is the shape of the container in which we are taking the solution, that is the path length of the light or the path of the light. So if we take for suppose if we have a dilute solution in a dilute solution of a colored solution in a cube shaped container, so that the light traveled through 1 centimeter can be enough, hence the absorbance isn't likely very high. On the other hand, if you have passed the light through a tube of 100 centimeters long containing the same solution, more amount of light would be absorbed because it interacts with more molecules, since the path of this tube-like structure will be more. Similarly, if you want to draw sensible comparisons between the solutions, you have to allow for the length of the solution and the light is passing through should have a fixed wavelength. If you are taking, it means if you are taking a series of solutions, if you want to calculate the concentration or the absorbance of these series of solutions, you have to consider the same shape of the tube or same shape of the container in which you are taking this series of the solutions. If the change in the shape of the container, as the path length changes, the absorbance also changes. Hence both concentration and the solution of the path length are followed by the Beer-Lambert's law. So the relation between the absorbance and transmission of a light can be determined by T, that is amount of transmittance is equal to I by I naught, that is transmittance is equal to intensity of incident radiation by the intensity of I naught is the intensity of the original radiation, incident radiation, by the intensity of transmitted radiation. So here the amount of light that is transmitted by the molecules will be equal to the ratio of the intensity of transmitted radiation to the intensity of incident radiation. What are the events that can occur or that can happen in a cuvette containing a sample? So if you are taking a sample, a solution, a colored or non-colored solution in a cuvette, when we incident a light with a particular wavelength, first it may reflect. The reflection and interference losses, they could be the reflection and interference losses because of the walls of the container, and the other can be some part of the light will be absorbed by the molecules and some part of the light will be scattered and some will be transmitted. Thank you. So these are the